Okay, so yesterday, or the last class we met, we did circles. And today we are going to talk about something called an ellipse. An ellipse is kind of like an oval. It's kind of a well, an oval. It's a stretched out circle. Now, the way the formula works for an ellipse, it looks very similar to a circle. We have x minus h squared and y minus k squared. So our center is hk. So your center is still hk. But notice that we have these fractions with something squared and something squared. Well, if I look back at my circle formula, remember they had the same distance from the center to any edge around a circle, and it was r squared. If I divide both sides by r squared, I would get x minus h squared over r squared plus y minus k squared over r squared equals 1. Notice that's very similar to what I have for an ellipse. A circle is kind of like a special ellipse. The distance from the center horizontally and vertically is the same. In an ellipse, it's different. So the number that's squared underneath the x is going to give me the distance from the center to the outside edge horizontally in the x direction. And the one under that's being squared underneath the y is giving me my distance from the y, from vertically from the y, like so you're going up and down vertically. Now there's also something called a focus, which is a really important point in an ellipse. And it kind of is where all the, for lack of a better term, energy is going to in an ellipse. And there's two special places that are called focus points. And we'll talk about how to find those in just a second. But first, we're just going to graph and see what an ellipse looks like. So x squared plus y squared. So I'm starting off with nice ellipses that have a center of 0, 0, because we'll get to moving them around in a minute. The number under the x is going to be my a squared. So a is 5 and b is 4. That's b squared and a squared. Okay, so what that's telling me is my center is at 0, 0. 5, okay, so that's underneath the x. So that means horizontally, I'm going to go out 5 each way. The 4 is telling me I'm going to go 4 each way up and down. It's kind of like my vertical radius and my horizontal radius are different. And I get this oval. Now notice we're longer horizontally. My focus points are going to be going horizontally. They're always on the larger axis. Now to find where these focal points are, we have a little formula. C squared equals a squared minus b squared. And notice it has those absolute value symbols around it. That's because, well, we need to, one of these may be bigger than the other, so we got to be careful about that. We don't want to subtract and get a negative number because we can't take the square root of a negative number. So we got these absolute value signs around it, just saying that we're going to make sure it's positive. So 25 minus 16, whoops, that's a minus, is 9. So c squared equals 9. That means my c, my distance from the center to the focal point, is 3 steps. So I'm going to go 3 steps horizontally since I'm longer horizontally. So I'm going to go 1, 2, 3, and 1, 2, 3. Now, something kind of interesting about focal points, there's a reason why the Oval Office is oval. There's also some buildings that are built oval, and there's always this whisper spot where if you stand at it, you can hear anything anybody says because the sound waves will bounce off the walls and go to those little focal points. So they're pretty neat. So I went from the center 3 steps right and 3 steps left. So that would change, those points would be at 3, 0 and -3, 0. So I'm adding 3 and subtracting 3, going horizontally. The next one is going to have a center at 0, 0. My X distance, my A, is going to be a 5. My Y distance, my vertical distance, is going to be a 10. So I've got 0, 0. I'm going to go 5 left, 5 right, but 10 up and 10 down. Ooh, big, 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 big. So this is longer in the vertical direction. Okay, so let's find our focal points, our foci. We're going to do the absolute value of a squared minus b squared. So we're doing the difference between our squared numbers, the ones underneath in the formula. So I got 25 minus 100. That'd be 75. It'd actually be a -75, but we're taking the positive version of it. So C equals the square root of 75. You could leave it like that, but you could also go to the calculator and get the simplified version. It's 25 times 3, so 5 square root of 3. Now, that is a decimal. I'm not quite sure where it's at. If I go to my calculator, I could find out where 5 square root of 3 is. I know it's less than 9, bigger than 8. So it's between 8 and 9. It's somewhere up in here and somewhere down in here. Why did I go up and down? Because that axis is longer. So I'm going to add 5 square root of 3 to my y value. I mean, going up, and I'm going to go down 5 square root of 3 from my center. Now let's see if we can go backwards and from a picture, find all my key features. So center is at 0, 0. The horizontal distance is 3. The vertical distance is 2. That means my equation would be x squared over 9 plus y squared over 4 equals 1. Let's see if we can find our foci. C squared would equal the absolute value of a squared minus b squared. So c squared equals 5. And let's see, it's longer horizontally, so that's going to go, we're going to go right square root of 5 and left square root of 5. Number 4, center is at 0, 0. My horizontal distance, let's see, 1, 2, 3. That's hard to see on here. I think it's at a 2. And I think that's at a 7. That would give me x squared over 4 plus y squared over 49 equals 1. My foci, c squared equals the absolute value of a squared minus b squared. That would be -49, but negative 45, but absolute value takes the square root of that. Absolute value takes the positive version. If I take the square root of 45, that's 9 times 5, 3 square root of 5. And we're longer vertically, so we're going to add that to our center and subtract. So we're going up and down from our center. So 0, 3 square root of 5, 0, -3 square root of 5. Last one. Feel free to pause the video and then check to see if you got it right. In our next lesson, we will be looking at shifting our center.